Thank you. So we're going to present our system for the entity detection and linking for this conference. So we've divided this presentation in two parts. I'll be presenting the name entity recognition system we built, and Cher here will describe the linking process that we've been working on. So as you know, the main challenge of the HIPE conference is to explore a large archive of the historical newspaper and do the name entity recognition and the name entity linking process out of it. And so I'll just describe, since we are the first person to present the linking process, we'll just describe it. So as it works. So the idea of the entity linking pipeline is to identify the entities of a reference knowledge base that are mentioned in a textual document. So for instance, in this sentence here, we've got Steve Jobs is the co-founder of Apple. We want to have for the final result that Steve Jobs is linked to this entity here, to Wikidata, and Apple, the organization, is linked to this entity here. And to do that, there are three steps that we'll describe. First, we want to do and perform the name entity recognition, so find the name, the organization on that. Second of all, since we've get those name entities, we want to generate candidates out of that using the knowledge base. And then we will exploit those candidates and make a ranking out of them. And best candidates is the one that will be linked to the knowledge base. And our approach for that is a bit different for the name entity recognition, is a bit different from what was presented before, because what we wanted to know, to explore is, could we benefit from the name entity linking to improve the name entity recognition process? And for that, we were focusing on the course annotation, so just only the first column of the file.
Sorry, just a small interruption to ask you kindly, could you please turn off the notifications? Because we hear a very frequent chat beep, so that would be fantastic.
We're aware of that. Unfortunately, I don't know where that notification is coming from.
Okay, then never mind. Just continue with the talk. If it was possible to do it easily.
I'm deeply sorry about that. We will try to move. I suspect it's related to Zoom.
Yeah, I think it's related to Zoom, and I tried to disable this. We didn't have in the first session. It's a chime sound which comes when people join in, and I have disabled it.
Yeah, it's painful. So
I'm really sorry.
Okay.
Sorry about that. Okay, I'll continue, I guess. Okay, so what we want to do, to sum up, is to first fine-tune the baseline. So we're not coming up with a powerful deep learning system. So we just want to take the basic CRF model, trying to fine-tune it, and then exploit, do the linking step, and then exploit the result of the linking step to see if we can do something to improve the NER results. So to fine-tune the baseline, we added more features on that. Just basic feature, the ASCII equivalent of the token, the condition on whether the token matches a date regex, and the first 100 elements of the fastest vector that was given by the organizer. We've only taken the 100th elements for computational reason. More of those features and parameters are available on our article. So now we've done the NER result, the name entity recognition. We handed that to the linking part. And then the question is, how can we exploit the results of the linking parts for improving the name entity recognition? So there were two things that we did. First, we're trying to correct the entity type. If an entity is found by the NER, it's associated to type, for instance, organization, a person. We do the linking process, and then in Wikipedia, there's also a type of the entity. And we were trying to, what we did is, the NER found the tokens, found the entities. We handed that to the NEL process, and then we are just correcting the category of the name entity using that. It didn't work very well. At least we are not able to improve the results. So we are trying something else. We tried to generate closely related entities. When we do the candidate generation, we have an option to get similar entities that we might find in the corpora. And to use that, to benefit from that, we did two steps. We tried two things. First of all, we tried to implement a rule-based approach to correct the unfound entities. So if using the linking process, there are new entities, new tokens that we have not found in the text originally using the CLEF, we will just do rule-based. So if it's a new entity, then it might be a new entity, and so we will label those entity directly. A second thing we tried is to use those entities as a feature for a retrained CLF. So if a token, so we get the list of candidates or the list of friends that we might find in a text, and we use that as a new feature for the CLF. But unfortunately, what we found is we were not able to successfully use the NEL result, the name entity linking result, to improve the first original name entity recognition results. I'll now let Cher explain the linking system we've developed.
Thanks, Guillaume. For the name entity linking, there are, as Guillaume said previously, two steps. The first is the candidate entity generation, and the second is the ranking. So for the linking, we assume we are given a document made of mention that are already identified, and the idea is for each mention, we're going to generate a list of candidate entities, and then we will try to select the best candidate entity for each mention. One possible solution is to define some similarity score and then select the entities that maximize the similarity. But this solution doesn't take into account the context that all the mention have in a document. So we rather advocate for collective entity linking, which is quite similar, but the only new thing is collective entity linking will try to maximize the similarity between mention and candidate entities, and also the similarity between all the candidate entities that we are going to select for the mention in a given document. So this will allow to benefit from knowledge-based semantic to improve the linking. And also this reduce the linking to the definition of three things: the similarity score for mention entities, the similarity score for candidate entities, and the optimization. And the optimization can be graph search or limit run. So we're going to detail each of these steps that we are choosing for our system. For the candidate entity, quickly, we are using CrossWiki, which is online resource based on Wikipedia, and the Wikidata search. We just use the mention and search for it on Wikidata. For the local score, we tried three different metrics: Levenstein distance to reduce OCR noise, the cosine similarity for the semantic distance, and the popularity for statistical also distance. For the similarity between candidate entities, we are using semantic relatedness measure, which benefit from RDF knowledge graph. Here we are using Wikidata, which is one of these knowledge graph. And the idea is to weight entities based on the relation they have in a knowledge base. And this will allow to incorporate semantic of the semantic distance between this entity and the knowledge base, and that will be somehow used to select the best candidate entity for the mention. And finally, for the ranking step, we are using a learn to rank method. The idea is to train binary classifier 0 or 1 for a couple of mentioned candidate entity. 0, they are not related, and 1, they are. And we are using the feature described earlier, the cosine similarity, Levenshtein, and popularity. For the global score or the global coherence, we are using both the sum and the max. This max is the best score at the best first, second, or third score. Actually, after third in general, it's is 0. And for the ranking, we are using the posterior probability. Now, quickly for the result of our NER and NEL systems. For the NER, we are only reporting the result for the comparing our system to the baseline on the diff file on French dataset, and also the result for the test file. We don't report the result for other competitor. And the NEL, which has both the NER and the NEL actually, it's the bundle 2. The results are quite nice, and here what is interesting to see is the collective entity linking versus non-collective. Actually, it's improved a little bit. So maybe the candidate entity generation stage is not very effective because we are just using very simple web search. To conclude, we propose the entity processing system that uses the CRF for named entity recognition and collective entity linking for the NEL, and that incorporate knowledge-based semantic with the WSRM metric, and it show actually not bad results. And as perspective, we can, as discussed previously, try to understand why this incorporating this knowledge semantic in the NER stage is not working, because we have negative results. But we think it may be interesting to dig a little bit. It's also maybe interesting to do an end-to-end system that will do both of these two tasks. Will do these two tasks at the same time, the NER and the NEL, and we'll try to reduce the errors, to minimize errors. And finally, it will be also interesting to try a more effective candidate entity generation system rather than just searching for the mention in a web page. And also here, because there are like OCR noise, it's not very effective actually to base only on the. Okay. Thank you for your attention, and please, if you have any question.
Sorry for the notification pop-up sound.